Hello and welcome to the second part of the free photogrammetry pipeline tutorial, in which we explore the 100% open source, accessible and cross-platform pipeline for creating amazing photorealistic 3D from photos. In the previous video we used Darktable to develop our raw photos and Meshroom to generate 3D geometry. We also utilized Blender as a general cleanup tool. And in this video we'll use Blender as a baking tool to reproject diffuse, normal and even displacement textures onto the low poly version of the mesh to make it game ready. As a refresher, that's how our raw scan made in Meshroom looks imported in Blender. You can find this file in the project files, feel free to download it. So currently this mesh is fairly heavy. It has 1.7 million triangles and faces for that matter, because it was triangulated. And once again, both the blend files and the OBJ file used for this tutorial can be downloaded. We'll require these files in just a moment to be able to follow along, so it's recommended to get it. So I think we're ready to start our Blender baking adventure. First we'll need to go over to our import menu to get the OBJ file in. Click import. It could take a few seconds if it's heavy enough, but here we go. I'm gonna rotate the model so it sits on top of the grid, and to aid the rotation I usually set the origin to geometry from the right-click menu, and then it's the usual business of snapping the object into place by utilizing G, R and S hotkeys for grabbing, rotating and scaling it. And it's easier done in the orthographic projections that can be brought up by the help of the numpad keys. Next we should probably smooth out the normals of the object, so right-click, shade smooth. Actually it's fairly important to keep the normals averaged or smoothed out before any kind of texture projection. To organize the scene a little bit and prepare it for baking, I'm gonna create a new collection and call it HP or High Poly. And while we are at it, let's also rename the object accordingly. So High Poly is the name. As you remember, we have had the diffuse texture somewhere. Let's hook it up to the principled BSDF shader. So here is the shader editor, and let's drag our EXR texture into it and plug it into the base color socket of the material. By the way, the color space is still set to linear, or it could be non-color, that's the same thing. Now to be able to see this texture, we need to jump into the rendered mode in the viewport. Maybe I'll also increase the strength of the environment light. Alright, so the high poly version is approximately 1,700,000 triangles or faces. Our next mission objective is to derive the low poly version by simplifying this monster. That's our plan. Let's duplicate the mesh and crunch down the density of polygons considerably. I'm renaming this object to low poly and putting it into its own collection called LP. Probably the easiest way to turn the high poly version into its low poly counterpart is to utilize the decimate modifier. If you have a look at the modifier settings, you will see the face count displayed at the bottom. Right now it reads 1,700,000 polys. If we enable the wireframe, we'll probably have a better taste or better look at how we crunch down the poly count. So the ratio of 0.1 reduces the poly count by the factor of 10, obviously, and what I usually like to do is apply the modifier and then add the second iteration of it. So modifiers, decimate. By doing it like that, we make sure that it behaves in a more responsive and fluent way generally, and it's just easier to fine-tune, I guess. So, reducing the ratio down to 0.05 or even 0.03 produces 5K faces. That should be totally fine even for real-time applications, I think. Removing the material just in case. And before giving it the green light, it's useful to preview it in the solid shading mode. I see some mesh artifacts that bother me, so I'm gonna increase the ratio ever so slightly and apply the second iteration of the decimate modifier. So this is gonna be our optimized version of the model with the face count of approximately 7,000 triangles. That should be an okay poly count for the modern game engine, kind of an average one for this type of an asset, I think. So now it boils down to making it look as cool and as high poly, I guess, as possible. You guessed it, via baking. There's just one more thing left to do before actually baking the textures. It is creating the UV map. So in the second window, I'm opening up the UV editor, selecting all the faces in the edit mode with the help of the A shortcut, then pressing U and selecting Smart UV Project as the fastest unwrap option, almost an automatic one. The defaults should be fine, let's confirm. After seeing this huge island that represents the ground, I think we can select it by pressing L, then S to scale it down a bit actually. And then select everything by pressing A, go UV, and let's pack it. Now the UV space is used in a slightly more efficient way that prioritizes the object and not the ground. Even though it's not perfect, it's much better this way. Now, when our low poly model has been successfully unwrapped, we can figuratively put it in the oven. For baking. In the oven. Anyway. Alright, to keep the workflow free and open source, we're gonna be using Blender for baking textures in this part of the tutorial. It has a few minor quirks, but it's totally doable. So first of all, I'm gonna toggle off the visibility of our high poly mesh in the outliner and enable the collection with the low poly mesh instead. As a quick reminder, it has been simplified to approximately 7,000 faces, and the UV map has been already generated as well. So our cunning plan for baking the displacement map from multi-res in Blender looks like this. First, we need to capture the details from the high poly mesh by adding the multi-res modifier and the shrink wrap modifier. That's our magic combo. We'll subdivide our multi-res a few times to give it enough resolution, then the shrink wrap modifier will capture the geometric details from our source high poly object. And then, eventually these captured details will get pushed into the multi-res again so we can bake it as a height map. Don't worry if it doesn't make sense just yet, we'll get into the weeds in just a moment and we'll show the whole process. For now, let's actually don't forget to select the high poly mesh as the target for shrink wrap. To capture the full range of surface intricacies, we should probably bump the resolution within the multi-res modifier. So I'm gonna click subdivide, and that will increase the resolution of the geometry. And you can already see by its changing shape that it inherited the detail from the high poly mesh. That's shrink wrap doing its magic. So let's subdivide it once more for even better effect. And it's looking quite good already. Let's check how many polygons did the original model have. 1.7 million. So that is our target. That is the reference number of polygons we should drive our low poly multi-res geometry to. Or rather triangles, because the low poly model hasn't been triangulated yet. So currently it measures approximately 81,000 faces and 163,000 triangles conversely. So ideally the number of triangles after we subdivide it a couple more times should correspond to or be higher than the number of polygons in the reference model. So let's click subdivide once again within the multi-res modifier and let's see what the poly count will become. Alright, we got approximately 300,000 faces, not nearly enough, so let's try our luck at subdividing it once again. We should probably keep in mind that each next level of subdivision will make it progressively harder for computers to calculate, but anyway, if we take a look at the statistics, we'll notice that currently our multi-res mesh is 2.6 million triangles. So technically it's even more than 1.7 million triangles of the original high poly mesh. So that is more than enough geometry to capture all the detail. What about the quality of the shrink wrap geometry though? We can definitely tell that even though the form has been captured pretty well, there are noticeable artifacts. I believe that some of these pinching issues can be tweaked by changing the wrap method to target normal project within the shrink wrap modifier. But still, it needs some more work. And I'm not entirely sure that target normal project was an improvement. You know, that happens in computer graphics all the time. We think that we improve stuff while we actually make it worse. That's classic. We can tell by these overly thin polygons that something is way off with the mesh, so let's probably roll it back indeed. The nearest surface point then is our choice. And poof, now the pinching is gone. I think our faithful shrink wrap modifier did its best, so we can apply it. So all the changes caused by the shrink wrap modifier get pushed into the multi-res. It's very useful because that's what we are gonna be baking. namely the difference between the final amount of subdivision within sculpt and render, which is set to 4, and the viewport subdivisions that will eventually be set to 0. That will be our difference between the low and high resolution that will end up being rendered as the height map. So let me switch the viewport levels back to 4. It's almost ready for baking, I think. But first, we probably have to do something with pinching. It's no good to leave it like this. I think sculpting comes to the rescue once more. So Control Tab, Sculpt Mode. T opens the left tool shelf with all the brushes. Now we need some kind of a smoothing solution. In addition to the smooth brush that can be invoked by pressing Shift and the flatten brush, we have a very intriguing one called Mesh Filter. We can click on Inflate and change the mode to Relax instead. And now just click and drag and watch the whole thing get progressively more and more relaxed. Until it is completely chilled out and there is no visible pinching, I guess. Awesome. Simply awesome. I think we have prepared the multi-res data for baking. Now it's time to actually bake it. Finally, I'm going back over to the object mode and I'm preparing mentally for the baking process, which is going to be a little bit hardcore. Probably the biggest weakness of Blender compared to other baking tools is its inability to bake height maps from one model to another. Fortunately, we have this multi-res displacement baking workaround, where we bake detalization from the higher sculpt levels to the lower, but still it's not quite there. It's still not as intuitive as some other baking applications. That being said, by prioritizing Blender as our baking tool, we keep this workflow A, open source and free, and B, cross-platform. That's a major advantage, so let's roll with it. So what we're gonna do is bake 3 maps. The displacement map from multi-res modifier, the normal map from the high poly version of the model, and the diffuse map or the base color map from the high poly version as well. Let's start with the trickiest one, the height map. The basis of how the multi-res displacement baking works is that it takes the difference between the sculpt subdivisions and the viewport subdivisions, and it bakes this difference as a displacement map for the minimal subdivision level for the viewport. It is important, even crucial, to define what is our minimal level viewport subdivisions that we are baking for. In this case, we zeroed it out, so that's our minimal level. Okay, as Eevee currently doesn't support any kind of baking, we should switch over to cycles instead. It is very easy to miss this step and go, where are the baking settings? So, cycles. And as for the samples, we don't need that much. Actually, just 8 samples will be quite enough for the type of baking that we're aiming for. Now we have the bake from multi-res checkbox ticked and the bake type set to displacement. That's practically all we need for our multi-res height map baking workaround, our secret sauce of baking displacement maps in Blender. Now in the upper left corner of the UI we have the shader editor. I have created a bunch of blank image texture nodes in advance. Basically you can add those image nodes from the Shift-A menu. I just did it in advance to save some time. So let us zoom into the first one, that will be our height map, and press New to create a new image file. We can be brave and set the resolution all the way to 4K, knowing that the baking process will actually be super fast. Let's call it displacement_bake. And it's also crucial to enable 32-bit flow checkbox, otherwise the displacement will have this weird stepping effect. After a new texture has been added, it can be found in the image editor. For now it's just black. I think we're ready by now to press the bake button with the displacement_bake image texture selected in the shader editor. That's important. Oops, no objects found to bake from. I think we simply forgot to do something. We forgot to select our object in the viewport, most likely. We can either click on it in the viewport or in the outliner. We should tell that it has become an active selection indeed by seeing an orange outline. That was easy to fix, right? Now let's click bake again, and it should go without a hitch. Luckily it's so fast to bake this type of texture, we should see it almost immediately in the image editor. Let's just pack it or save it externally, however you like. Otherwise, we will lose it on quitting Blender, and that will be such a shame. Packing textures instead of saving textures has its own advantages and disadvantages. I did it to save some time. And anyway, the packed textures can be extracted into the folder with the blend file automatically. It'll even create a nice folder named textures for you conveniently. But if you're gonna save images by going Image, Save As, that's totally up to you, that's fine. Alright, what should we bake next? Now the second texture will serve as a normal map. So let's click New, call it normal_bake. The resolution is set to 4K. Let's disable 32-bit float now and hit OK. Once again, it is important to select this particular image texture that you're going to be baking to. And with that done, the bake type can be changed to normals. So after selecting the normal_bake image and hitting the bake button, we should see the progress bar firing up at the bottom of the screen, and if everything goes right, get our normal map. Oh, the time flies, just a few seconds passed and we already have the normal map generated. Let's preview it out in the image editor to see if everything seems to be correctly generated. And personally, I have no objections, I think everything looks smooth. Now let's see what is still left to do. Well, first of all, before I forget, let's set up a proper displacement chain. Here I prepared an empty image texture coupled with the displacement node in advance. Let's disconnect it, move it to the left like this, and let's use the height map or displacement that we have baked from multi-res modifier. And it should go into the height input of the displacement node. Okay, and this empty texture node will become a holder for the base color texture. Clicking on New and calling it just like that. Base color _bake. The base color texture doesn't have to be the 32-bit float image, so I'm leaving this checkbox empty. And confirm. Don't forget to pack the textures, or save them externally for that matter. This time we won't use the multi-res modifier as a source of baking data. We will use our high poly mesh with the diffuse texture instead. So let's toggle the visibility back on in the outliner. Select the high poly, then control click on the low poly and make sure that that's the last object selected. Now we need to come over to the bake settings and change the bake type from normal to diffuse. Here it is. We are interested in the base color only, so both direct and indirect contributions should be turned off. Then it's absolutely crucial to get the selected to active checkbox ticked. That's why we have two objects and we are baking from one to another. As for the cage, we won't be adding a custom one. What we need to do though is adjust the extrusion. It creates a ballooned out version of a mesh to cast the rays from, so it's a safe bet to set it to a lower number like 0.01 or 0.02, something like that. Let's check the high poly model though first, because I have an impression that we have lost the diffuse texture somewhere. Let's check it out. I'm disabling the visibility of the low poly, switching to material preview so we can preview the diffuse texture, and indeed it looks blank. It looks like I managed to lose the diffuse texture along the way somehow. Let's inspect our high poly, and indeed, where is the texture? What's going on? That is awkward, but what I usually do in such cases is search in the image editor. And actually, here it is. It just has to be plugged back into the base color. So I click and drag it like this, and it goes into the base color. Hopefully that will bring things back to normal. So with this issue fixed, we can give it another try. I selected the high poly model first. Then let's enable the visibility of the low poly one, shift click on it. Then we can try to hide the high poly temporarily to see what we are doing. And it is super important to select the texture that is going to be used for baking in the shader editor. And with all the rituals fulfilled, we can at last return to the baking menu and hit the button again. Whoops, it prompts an error, no valid selected objects. I think we need to enable the visibility of the high poly mesh as well. That should do the trick. And then select both meshes with the low poly being the last one, and hit bake again. We can see the progress bar firing up, and that's the good news for us. Well, what's going on? Why the texture is black? We should probably disable multi-res modifier and try that one more time. You see, it's a bad omen to say the good news, because there is no good news in computer graphics until you actually see the rendered result with your own eyes. Baking again. So after a few miserable attempts of reprojecting the base color from high poly to low poly, we succeeded, and that's a good news, folks. Now we just have to save the image, or rather pack it. From now on, it will be a part of the blend file. And now it's time to build the material. So base color goes into the corresponding input of the principled BSDF shader. And as you can see, it looks pretty lifeless and flat. That's because we need to reconnect the rest of the inputs. Yes, our baked normal map, I'm talking about you specifically. In order to work properly, it needs the normal map node from the shader editor. It can be found in the vector tab. And before we use this normal map, it's important to switch the color space to non-color or to linear. Otherwise the bump mapping will look terribly off and totally crazy. So it goes into the color of the normal map, and then it is silently hooked up to the normal input of the material. Alright, that's looking much better already. To take it to the next level, we can make use of the displacement map that we have generated. As a quick refresher, the displacement map setup in Cycles looks like that. We have the baked height map, which goes into the height input of the displacement node in the shader editor, and in turn, this displacement node goes straight into the material displacement input. Then, to finalize the micropolygon displacement setup in Blender, we need to do a few things. First of all, we need to set up the subdivision modifier. Here we go. And enable the adaptive subdivision checkbox within this modifier. If you don't see the adaptive subdivision checkbox right away, it means that the Cycles feature set should be switched over to experimental first. And then the checkbox with the new option should appear in there, and it has to be ticked. But that's not all. Lastly, we need to visit the material settings. Scroll down all the way to the bottom of the settings until we see the displacement drop-down menu. There we need to choose displacement only. And hopefully after all these manipulations, we would be able to enter the rendered mode in Cycles and see the micropolygon displacement come into play. After some testing, we found out that after baking the modifier from multi-res data, the scale of the displacement node should be set to something like 0.05. That practically makes it look very close to the high poly version of the mesh, and so we think that's pretty close. Evidently, the scale of 1 is way too strong displacement for the height maps produced via baking from multi-res. So the scale of 0.05 seems to be the sweet spot. And in addition to that, the mid-level should be set to 0.5, but that's the default value for it. So we don't have to worry about it that much. It is worth comparing two meshes to make sure that we nailed the displacement settings indeed, because it can be pretty tricky to do right. So here is a quick comparison between the raw high poly scan at the bottom and the low poly version of it with the Cycles micropolygon displacement at the top. These two models look fairly similar to me. I think we can write it as a success. If you feel like watching a few more comparisons, here's how it looks in Cycles with micropolygon displacement turned on. Pretty awesome. And here is the same mesh but rendered in Eevee this time without any displacement. Just a good old normal map applied. And in my opinion, that also looks pretty cool and detailed and realistic. It is still based on the photoscanned asset, and that's what gives it its charm. Obviously, the realistic clothy stuff like that is notoriously hard to make in 3D, so starting with a photoscan is a blessing. It is amazing how far we went with the open source cross-platform photogrammetry pipeline, right? It is crazy to think that we can do all of this without buying any kind of software. And even though it's far from being the fastest workflow ever, but anyway, that's super impressive that we can set up the full photogrammetry pipeline by using only open source and only cross-platform tools. that makes this entire workflow super accessible pretty much to anyone. The only bottleneck I see currently is the hardware issue rather than software issue, which is an NVIDIA GPU is still required for most of the operations in both Meshroom and reality capture, if you're gonna use reality capture for the same thing. Aside from that, that's super accessible, really. Thank you for watching. My name is Gleb Alexandrov. You're watching Photogrammetry course, in which we explore various ways to create amazing photorealistic 3D from photos.